Hey everyone, in this video I am showcasing a production grade medical prescription analyzer built using the Qubrid AI Qwen3 Vision model. Before we jump into the demo, here's what I will cover in this video. First, I will show you a live walkthrough of how the system analyzes a handwritten prescription end to end. Then we will break down the 4-step reasoning in pipeline implemented inside the project, and I will show how prompts are engineered to enforce medical safety and structured outputs. And finally, I will explain why using Qubrid AI made this project production ready. Now let's start by seeing the project in action. This application is built using the Qubrid AI Vision API model Qwen3 with LangChain handling multi-turn step reasoning. The interface is built in Streamlit with SQLite is used for persistence. Now I will upload a handwritten prescription. As soon as the image is uploaded, the system detects it and begins analysis. As you can see, it is showing verifying new image. At this point, the image is being passed to the validation layer first. This system checks whether this is actually a medical prescription before doing any extraction. This is a very critical and important step. Once validation passes, the vision model extracts medical entities like medicine name, dosage, and then normalizes everything into a structured format. This entire process happens through a single multimodal reasoning pipeline, not separate OCR and NLP steps. As you can see, the extraction is in progress and the model will be extracting medicine name, as you can see in the here. Here is the original prescription, and you can see that it extracted the medicine name, dosage, frequency, and timing. Here is the handwritten clarification required feature, for which the model takes the user input from the things it is not clear about. And as I can also say that it's one tablet in morning and one tablet at night, and it will update it. I can also chat through it when to take augmentin medicine, and the model will extract to the respond to the information it extracted to the prescription, and it will also give a disclaimer that it is a AI generated prescription, not a doctor's advice. And we can also create the schedule of our prescription. See, it has created a wonderful schedule. So it converts the structured information into a clean, easy to read daily medicine timeline. And finally, the schedule can be exported as PDF, including the table and when to take the medicine. This is ready to save or print. Now that you have seen the output, let's look at how this works internally. So all of the reasoning logic lives inside the class VisionChain. The first step, the pipeline is explicitly broken into the 4 steps. Okay, so step 0 is classification. The first model calls checks whether the uploaded image is actually a medical prescription. If this fails, the pipeline stops immediately. Now, step 2 is the OCR step. Once validated, the model extracts medicine names, dosages, and intake frequency from the image. Step 3 is normalization. This raw output is converted into a strict JSON schema, ensuring the data is structured and predictable. Now the step 3-4 is safety audit. Finally, the pipeline evaluates ambiguity and confidence. If the handwriting is unclear or the confidence is below threshold, the system flags the result instead of guessing, which is critical in medical prescriptions. Keeping these steps explicit inside VisionChain, it makes the system modular, debuggable, and safety first. Right after the pipeline logic, this file prompts.py defines how the model is instructed at each step. Instead of a single generic prompt, I use task-specific prompts for validation, extraction, and normalization and safety audit. Each prompt assigns a clear medicine role, a structured JSON schema which prevents hallucinations and ensures consistent safe outputs. Separating prompts from logic also makes the system easy to maintain and extend. What makes this project practical? was Qubrid AI. With a single API key, I was able to access hosted multimodal vision models, GPU powered inference, and seamless deployment without managing any infrastructure. That's why this application feels like a real product instead of an experimental prototype. You can see Qubrid AI gives us many state-of-the-art models like OCR, vision, audio, image, code, and text, and you can all access all of them with the help of a single API key. Building this project showed me how powerful multimodal visions can be used, and they are wrapped in a safety first architecture. If you want to explore the code or build this yourself, the GitHub link is in the description. And be sure to check out the Qubrid's Cookbook official for more real world AI projects. If this video helped you, hit like, subscribe for more AI deep dives, and I will see you in the next one.